Hi dear, today we'll see refraction of light. Okay, so what is meant by refraction of light? Okay, when a light passes from one medium to another, its path changes. This phenomenon is called refraction of light. You know that we are for this year we are going to study that light travels in a straight path. Right. We are consider the nature of the light to be travel in a straight path. Okay, so it travels in a straight path only. Okay, but when it changes from one medium to another, okay, its path changes. That means it bends. The light rays bends. Okay, that is called the refraction of light. Okay, when the light passes from one medium to another, here the medium should be transparent. When the medium is transparent, then only refraction of light happens. Okay, this medium should be transparent. The medium should be transparent. Okay, and its path changes mean it bends. Its path changes mean it bends. Okay, when light passes from one medium to another, its path changes. Okay, this phenomena is called refraction of light. Okay, that is bending of light when it enters another medium. That medium should be a transparent medium. Okay, if it is an opaque medium or if it is a mirror, means the light will be reflected back, right? So it will not enter through this medium, right? So this is your incident, right? This is your reflected light. But refraction is when it enters this medium. When it enters this medium, this is one air. For example, this is air medium. This is another medium. When it enters this medium, it changes its path. We know that light travels in a straight path, so it has to go like that. But when it enters another medium, its path may changes. It may go like this or it may go like this. Okay, there will be a slight change in that. That is the bending of the light. Okay, that is called refraction of light. When light passes from one medium to another, that is one transparent medium to another transparent medium, its path changes. This phenomena is called refraction of light. Okay, so what is the causes of refraction? Why it happens? Why the bending of the light happens? It is due to the change in the speed of the light as it enters from one transparent medium to another. You know that the speed of the light is what? Approximately 3 into 10 to the power of 8 meter per second. So in air it travels at this speed. Okay, when it enters some other medium denser than the air or rarer than the air, its speed may increase or decrease, right? So its speed is constant. You know that in the air it travels at the speed of 3 into 10 to the power of 8 meter per second. But when it enters a denser medium, its speed may decrease. Okay, so when the speed changes or decrease, this bending of the light happens. Okay, it is due to the change in the speed of the light as it enters from one transparent medium to another medium. Okay, so the refraction is due to the change in the speed of the light. Okay, next. So how the here itself I told you it may bend here or this direction or this direction or this direction, but anyway it is not going in the straight path. Okay, so that bending, how it bends. Okay, so how the light bends. First, case 1, how the light behaves when it enters from rarer medium to denser medium. Okay, rarer medium to a denser medium. Okay, when light enters a denser medium, okay, you know that in air it travels with a speed of 3 into 10 to the power of 8 meter per second. For example, any transparent medium, a plastic or glass slab, like that, when it enters some denser medium, when light enters a denser medium, its speed reduces, right? Its speed will be reduced. It will not travel with the same speed. Okay, in the air it is constant. Wherever the air is present, wherever the light travels, it travels with the speed of 3 into 10 to the power of 8 meter per second. But when it enters another medium, okay, when it enters another medium, its speed will reduce. Okay, when it enters rarer than this medium, its speed may increase. Okay, so when it enters a denser medium, its speed is reduced and it bends towards the normal. Okay, and it bends towards the normal. In that case, see, so this is your, for example, take this is a glass slab. So this is your incident light, okay, when it incident the boundary of the another medium, right? So this is called the point of incidence, where it incident. This is your incident ray, this is the normal ray. You know that it is an imaginary line, okay. It has to, what is the property of the light, nature of the light? It has to travel in a straight line. It has to travel, goes like this, but here it bends towards the normal, okay. It bends towards the normal. In that case, this I is greater than this R. See, the figure itself, we are able to see this I is greater than this R. We will always measure the angle of incidence and angle of reflection with respect to the normal and the incident ray, normal and the reflected ray, right? Likewise, this is your refracted ray. This is your incident ray and this is your refracted ray. Always will measure with respect to the normal. Here I is greater than R. Clear on this? How it bends, I'll explain. Okay. So this ray we are consider it. We are consider this light rays, right? It is not a single ray, right? This is not a single ray. It is a beam of light rays. For understanding purpose, we'll take this as a single ray, right? Right. So if you consider this as a bunch of ray, you will be able to see how it bends. For example, I am going to show this single ray as a wave like this, like a beam of light rays, okay. So this is your glass slab. So first take this. Here it enters the denser medium, so its speed has reduced, right? Its speed has reduced, so it will travel very slowly. But here it is still in the rarer medium. For example, this is air, this is glass, okay. So how the waves will be, it will be like this, right? The rays at this point will travel more faster than the rays at this place, because it enters the denser medium. Its speed is getting reduced, right? So still it is in the rarer medium, so it covers this much space when compared to this side, okay. So now you are able to see this. So once it enters completely to this medium, so both the speed will, here speed of this full, all the rays will be same. Now you are able to see this bending of the light is happening here, right? This is how it happens, okay. So when it enters from rarer to denser medium, this speed has reduced, right? So it bent towards, see, we are able to see this, it is bending towards this, towards the normal, okay. So when light travels from rarer medium to denser medium, its speed reduces and it bends towards a normal. Because for representation we are using a single ray, incident ray, but actually it is not a single ray, right? It is a beam of light. It's a wave of light, full thick beam is coming. So here this part, when first it enters the denser medium, so its speed has been reduced, so it has covered only this much part, but still the rays here, it is traveling still in the air. Its speed is same, so it maintaining the same distance. It covers much distance, okay. So it's trying to bend towards the normal. Clear on this? So this is your first case. So here in the first case, it enters rarer to denser medium, I is greater than R. Here I is angle of incidence, R is the angle of refraction, okay. The second case is when it enters from denser medium to rarer medium, okay. When it enters from denser medium to rarer medium is what? See, it is a glass slab. This is your glass slab. This is denser medium. This is your incident ray. This is point of incidence. From denser medium, it enters the rarer medium. Okay. So when light enters rarer medium, its speed, what happens to the speed? It comes to the constant speed, 3 into 10 to the power of 8. Okay. So the speed will increase and it bends away from the normal. The light rays bends away from the normal. Okay, so same case, if you take a if you consider as a wave, okay, it travels like this. Okay, when it's going to enter the, see, when it's going to enter the rarer medium, the speed will increase, so it covers much distance when compared to here. It covers the same distance, still it covers the same distance. Here it will be like this. So it covers much distance because it enters the rarer medium. Still, but here it's still in the denser medium. So once it enters completely into the rarer medium, it travels with the same speed. Okay, so you can, if you are able to see this, it is bent away from the normal. For example, if is the normal means it bends away from the normal. Clear on this? Okay, if you see this, see this I is smaller than this R, or you can say R is greater than I. Okay, so when light rays enters the rarer medium from the denser medium, its speed will increase. Speed increases. When the speed increases, it bends away from the normal. The light rays bends away from the normal. So I is smaller than R. Okay, smaller than R. Okay, and one more special case is there. That is what happens when the light incident normally to the surface. Okay, what happens when a light ray is incident normally to the interface of two media. Okay, this is a special case. See, when enters from rarer medium to denser medium or from denser to rarer medium, the angle of incidence and the angle of refraction is equals to 0. Okay, you cannot see the bending of the light. Okay, but actually what happens means refraction of light is happening there. Refraction of light happens, and change in the speed of light is also happen. When it enters from rarer to denser medium, the speed of the light will be reduced, and also refraction is also taking place. Okay, but the angle of incidence and angle of refraction are equal. That is equals to 0. That is equals to 0 because the angle of incidence as well as angle of refraction lies on the same normal. Okay, what happens in this case? I said refraction of light happens. Refraction of light happens, but the bending of the light is not there. Okay, we cannot say refraction is not happening there. Only the angle of refraction is 0, but refraction of light is taken place. Because refraction of light means what? When it enters from one medium to another medium, then refraction of light happens. The bending of the light is due to the refraction. Okay. Okay, since the bending is not happened, we cannot say refraction is not happening there. Okay, refraction is happening there, refraction is taken place, and change of speed of light also taken place there. Okay, what actually happens means when it enters, when it incident on the second boundary, second medium, right? Then another medium, it tries to bend, right? But the bending of the light will be equal in all this case. See, when it enters it, which direction it may in which direction it has to bend, it does not know, right? For example, it has to bend towards the normal or away from the normal at 10 degree means which direction it has to bend, it will bend. See, for example, this is one medium, it enters here, right? It enters here. In which direction this angle of incident, angle of refraction will bend? We don't know, right? So because of the nature of the symmetry, you are having a 360 degree. For example, from the top angle I am showing that this is a point of incident. Which direction it has to bend, or which direction it has to bend away from the normal, it does not know. Due to nature of symmetry, it has to go straight. So it has to go straight. Okay, it cannot bend. Whether it has to bend in this direction 10 degree, or it has to bend in this direction or 10 degree, in this direction or in this direction, we don't know. Because of the symmetry, it has to pass straight. Okay, so this refraction of light happens here. The speed, the speed of the light will also be reduced or increased, but the angle of incidence and the angle of refraction will be 0. Okay, just equals to 0. Clear on this? This is one of the special case. In remaining these first two cases, when it incident obliquely, okay, obliquely, in case of when it enters from the denser medium to rarer medium, it moves away from this. Remember this diagram so that it will be easier for you to understand. When the speed increases, here it moves faster. First it reaches this place, this rays reaches this place, it moves faster, it moves away from the normal. Okay, when it enters from rarer medium to denser medium, so here this rays first enter the denser medium, so it reduces the speed, so it moves slowly, so it bends towards the normal. Okay, so this is how the light bends. When it enters from rarer to denser, it bends towards the normal, that is I should be greater than R. Your refracted ray will be greater than the incident ray. When it enters from denser to rarer medium, it bends away from the normal, so I is smaller than R. When the light incident normally to this normally on the interface, refraction will take place, speed of the light will also changes one, but the angle of incidence and the angle of refractions are equal, which is equals to 0 degree. Okay, thank you.